let me take the opportunity to call upon our next speaker, Dr. Khushbu Patel, AGM, Alishan Green Energy Private Limited. The topic she's speaking on is effect of temperature, humidity, and UV intensity on the volume resistivity of solar encapsulants. Yes, ma'am.
Hello and good afternoon, one and all. Am I audible? Yeah, okay. Yeah, firstly, I'd like to thank REI for presenting this stage to all of us, where we come from different background and different minds, but the aim is only one. We want to solve some of the problems, some of the flaws that are still there in the solar industry. And I would like to start my talk with a little background of my company, what we are doing. So we are Alishan Encapsulants and Backsheets. As you can see from the title itself, we are the manufacturer of encapsulants that goes inside the solar module for safety purpose, as well as the backsheet, that are the back planes that you use either instead of glass or directly use as the rigid support. So Alishan Group, one of the arms of Alishan Group is into renewable division, where we have encapsulants and backsheets. Encapsulants, currently we are at 3 gigawatt of capacity. We are quickly ramping up it to 4.2 gigawatt by December. And backsheet, we are slowly trying to expand the capacity, but currently, as all of you know, the trend is of G2G modules. So we are slowly looking at the market. We'll see if the demand comes up. We will definitely ramp up the capacity of backsheets too. We have a state-of-art facility where we can produce encapsulants of all kinds, like traditional EVA, the ideal encapsulant POE, and new champion, which will be EPE for all future needs like TOPCon or HJT or any other new technologies that might come in the future. The machines are capable of making encapsulants readily available for M10 and G12 modules. So the products are here. We have Alishan Front EVA that you use without the cutoff encapsulant, mostly in the front side of the module. Alishan FC with the cutoff, UV cutoff to protect the back sheet. But if you don't have back sheet in the configuration, you can directly use Alishan Front EVA in both the sides. Alishan POE, the polyolefin based encapsulant, which is relatively newer in the market, but because of the because it is not that much machine friendly, people have directly gone to the new encapsulant, that is EPE, the co-extruded films of encapsulant, EVA and POE. In backsheet, we have proprietary coating material. So we are promoting our own coating at the cell site, which will give you more UV protection. And we are promoting KPC, that is the Kynar based, PVDF based backsheet, and CPC in the transparent versions. So this is a quick business matrices that we'd like to tell you. The company is producing 20 million square meter per annum, that is the encapsulants, and revenue of both the companies, like renewable division, is roughly around 85 crores in the last year. Our top selling products are EVA, EPE and white backsheets for the year 2023, but in 2024 we are looking at more selling of transparent backsheets because of its unique uses in either roof mounting or even in the solar parks. 2024 year, as we have seen, is the rise of IEC standard, especially for encapsulants and backsheets. The standard initially also existed, but unfortunately people were not that much aware about the standard. So now our customers, like module manufacturer, are coming to us and asking what the standard says and how to do the testing at our end. However, after almost 130 years of discovery of this photovoltaic effect and 70 years of first solar cell, we are still trying to make the solar modules or even solar energy more sustainable. Now, I would not even say we are at the infant stage, we are before infant stage in the solar energy field. Reason is we have a list of testing and standards for the module itself, very limited criteria for encapsulant like ancillaries, and I'm sure my colleagues or my fellow partners in the industry who are making core ancillaries would be also feeling the same. I'd like to point one thing over here, that we have mechanical properties of encapsulants or optical properties that we look initially at, but the reliability part, which we are more concerned about, and that adds to the bankability as everybody is concerned about, is not even looked at in any of the standard. So, for example, to take the example of we are here, I'm not trying to put any allegation on the existing system. It's just a way forward that we all can work, and especially I'm also from academia, so my views are also blend like academician, what research should be there in the solar field. Reason is currently we are only lagging at the research and innovation part in India. Research is happening in the universities, in the labs where we come from, but there is definitely a gap where we need to bridge that research to the industry level, especially in the ancillary part. So we tried a small experiment. This is like not hi-fi research which you do in your PhD level, but the small experiment tells you very important thing. So we took the encapsulant, directly heat it up from 40 degrees to 120 degrees, which is not going to obviously mimic the module in the field phenomena. Reason is encapsulants are not directly given this much temperature in the field. Those are covered between the glass. And then what we do is we measure the initial and final volume resistivity. So the observation which we identified from the measurement itself were like VR values were not changing drastically. For example, your initial values are in the range of 10 to power 16. That range is managed even after the direct temperature application. So if I say and completely just draw the linearly decrement in the resistivity of the encapsulant, that doesn't make any sense. I had to look at the second order phenomena, or if you can say that I had to look at other properties which is temperature dependent. So very obvious thing when one is looking at temperature and resistivity is the Arrhenius equation. So when we plot the Arrhenius graphs, that is your log resistivity versus 1/T plots, and we see that there is some information that we can extract it out, and we can roughly say about the encapsulants and its competition. So the EVA, which is very much traditional encapsulant being used in the solar modules since its discovery, like in since 30 years or more, has the lowest activation energy. This activation energy represents the chemical activations and energy which is going on at the encapsulant level when thermal energy is applied. If you see POE, it has a roughly 4 times more energy than required for activation, and EPE is in between EVA and POE. However, if you see EPE, so traditionally it was thought that it's just a combination of EVA and POE. So it will be an average encapsulant which will have the properties of EVA also and POE also. But some of the results, not only VR, some of the results are telling us that it's not only the average encapsulant, rather it is more towards POE. And it doesn't only tell me about EPE as an encapsulant, it tells me more about POE. So POE, what we believe at Alishan is the crucial material to have in the module, which will inhibit the thermally activated processes. Moreover, EPE would be the future encapsulant. Reason is its commercial viability as well as machine superiority. Third one is we are values what currently we are getting from the machine itself. That doesn't tell us more about or anything about the reliability at the power plant level or at the 20-year scale. It's just a number that we can take initially, but we need to look at more phenomena like, as I'm talking about, like rate of reaction, what would be the acid leach out rate, or any other phenomena that we can directly correlate with the degradation mechanisms. So what we feel that thickness of POE roughly around 200 micron would be enough to have VR which is suitable for your solar module. Now, why I'm emphasizing on this thickness is, reason is, currently the module manufacturer are using more than 600 micron films in their modules for the encapsulation. In China, rather, people have moved to 350 micron films. How they have moved? Just by research and trial and error. So if POE is being used in your module, you need only 200 to 300 micron film and you are sorted for the reliability. Again, EPE, I would like to mention that is thought of as oil and water analogy, because POE is non-polar material and EVA is polar material. So we were thinking like it's like oil and water, it will not mix. But if you formulate it carefully, it can break that analogy and can give you wonderful results. So final takeaway would be, I would say discuss with your supplier, that is encapsulant and manufacturer, and choose the reliability consciously. Discuss with them more on the reliability part, not just the initial results of what they are offering, like IQC data, but discuss with them more on the reliability part. Thank you. If you have any question, I'd like to take it. Otherwise, we are exhibiting at booth number 9, hall number 9, booth number R105. So you're most welcome if you have any discussions, and thank you.